Hello, welcome to our analysis today. The focus here is a world that, wow, just won't stop changing. Robotics and the technologies that come with it, and how they are shaping the future. We've gathered some really interesting material here. It ranges from a humanoid robot taking some hits to new ways to store energy and futuristic displays.
The idea is to dive a little deeper into all of this, try to understand what's behind it, what it means for us, right? And perhaps even generate a mix of fascination and apprehension about this human-machine interaction. To begin, there are two things that got people talking. A robot head with incredibly realistic human expressions and a somewhat controversial video of a robot taking a beating in a test.
Well, let's unpack that. Starting with this rather rough resistance test, it's the G1, a humanoid from Unitree in China. In the video, it gets kicked, stumbles, falls. It looks like it tripped on a rug, right?
Yes, it looks like it was the rug. But what's shocking is it gets up in less than a second. Impressive. It's very fast, almost instantaneous. And the internet, of course, piled on. There were jokes, right? Oh, that one's going to get revenge when AI takes over. There's always that.
Even more serious people like, one day these robots will watch this. It leaves an unsettling feeling, A machine that withstands abuse like that. The reaction to what allows this resilience is totally understandable. Underneath it all is a lot of engineering focused on fast response.
They use permanent magnet synchronous motors in the joints. Think of an electric motor, super precise, almost immediate response. And there's also a dual encoder system that constantly reports where each joint is.
This allows for those micro adjustments, in milliseconds. So it's not just brute force, it's fine control.
Exactly. And it's not just the individual joint, it's the whole body working together, an integrated control system. For it to see the environment, it has 3D LiDAR that maps with a laser, like those in self-driving cars. Yes, similar.
And depth cameras, a balance sensor, the IMU, which is like our inner ear but electronic. Then comes the Unitree's AI. And how does it learn?
Well, they use imitation learning. The robot kind of watches humans doing things, even martial arts, dancing. I've seen videos of it dancing. It's kind of surreal. Yes. And they use reinforcement learning to refine everything, to walk, to balance, to perform those more complex movements.
But this thing about mistreating robots in testing isn't new, is it? I remember Boston Dynamics pushing Atlas.
Yes, there's a tradition there. Honda's Asimo also went through tests, but here with Unitree, there seems to be a different message, perhaps to show that the G1, which they say is more accessible, can also handle the real-world daily grind.
Exactly. It's a demonstration to say, look, he's not just agile, he's genuinely robust, ready for the real world, not just the lab. This gets to us, doesn't it? It does.
That line between the fragile machine and a partner that can take a punch is getting blurrier. It's fascinating and at the same time gives a certain apprehension, right? All that capability. Speaking of fine lines and strong reactions, wow, that robotic head from Redform, another Chinese company.
That one is impressive too. The realism of the expressions is incredible, especially the blinking. It's so natural it actually gives you chills, That uncanny valley hitting hard.
Totally. The uncanny valley in action. This is where things get really interesting. What do they want with this? Their declared goal is precisely to bring humans and robots closer, to use this emulation of emotion to make communication more fluid, more natural.
The idea is that to truly collaborate, the robot has to pick up on and react to our nonverbal cues, like a glance, a smile. I see. And how do they do that technically? It looks like magic.
Well, it's a combination. They use AI algorithms, which learn on their own, called self-supervised. And the key hardware is the so-called bionic actuators.
Bionic actuators, what are those? They're like micromechanisms that function as artificial muscles, allowing those super subtle movements of the face, To simulate a smile, a furrowed brow, the head has about 30 degrees of freedom.
Imagine 30 different ways to move just the face. trying to imitate our more than 40 facial muscles. Holy cow, 30. Yes. And they use brushless motors, which are smoother, respond quickly, and use little energy.
They have a line, I think it's called ELF, which has a design with large ears, a bit different, but the face remains at that level of realism. Yes, the focus is always on the convincing facial expression.
And the highlight in the videos is this feeling that the head is thinking, genuinely reacting. The way the gaze follows you, the blinking that seems to be timed just right, the lips moving with the speech. It's very convincing, easy to fool you. It goes far beyond a dummy, right? Absolutely.
And that's where the core question comes in, right? If technology can simulate emotion so well, how does that change our relationship with these machines?
Exactly. We might end up feeling empathy for a robot. Good point. The point here isn't just the technical realism, it's what it reveals about us. It demonstrates that with engineering, you can trigger in us the perception of emotion coming from something non-living.
This forces us to think about what it will be like to have service robots, assistants, maybe even companions with all this capability. It's a profound question indeed. Moving a bit away from the face, but still on humanoids, mobility is also soaring.
Over in South Korea, KAIST, the Korea Advanced Institute of Science and Technology. That's it. They showed a bipedal robot, just the legs and torso really, doing incredible things. It's impressive. Running at almost 12 kilometers per hour for a robot that size, and even doing the Michael Jackson moonwalk, that duck walk.
Yes, a robot that's 1.65 meters tall and 75 kilograms is quite agile. Seeing that is different, and it's not just showmanship, you know? The resilience tests they do are important. They push the robot, and it manages to stay on its feet or recover very quickly.
And there's a big highlight, the capability of blind walking. Blind how? Without cameras. Exactly. It can walk, go over obstacles, steps, uneven terrain, just using its internal sensors, like the IMU we mentioned before, and the AI control, without relying on external vision.
Wow, that's a huge leap. Yes, it is. It shows they're managing to lower that barrier between what the robot learns in simulation on the computer and what it can do in the real world, which is a huge challenge in robotics.
And what's the secret to that? It's a reinforcement learning algorithm. They train it so exhaustively in simulated virtual environments. Their lab, HumLab KIST, is achieving this simulation to reality transfer.
They will present more details at a major conference, Humanoids 2025, and they are already talking about the next step, having the robot manipulate objects while walking, like carrying a box up the stairs.
Exactly. It's a very complex challenge. Balance, coordination, strength, all together. And on the other side of the world, in the UK, the HMN01 Alpha appeared. It's from a startup called Humanoid.
Oh yes, the first British industrial humanoid, they say. And what's striking is the speed at which they made it. They say it only took 7 months from concept to prototype. That's fast, isn't it?
Very fast for a project of this complexity. And its focus is very much on the factory floor. Logistics, retail, manufacturing, no dancing here, heavy labor. Yes, the design shows it.
It's tall, almost 2.20 meters, but it uses wheels. Wheels? It's not bipedal. This industrial alpha version uses wheels for more stability and speed in places like warehouses, you know? It reaches about 7 kilometers per hour and can carry over 15 kilograms, I see. Function focused.
Exactly. Its brain is a robust platform, the NVIDIA Jetson Orin. It can process multiple AI streams simultaneously. They talk a lot about using generative models, advanced simulation, simulation for training.
Right. They use NVIDIA and ZXSim Omniverse to create synthetic data and train the AI before it goes into the real robot. And continuous learning, it gets better over time. The promise is a robot that thinks about the data and decides, not just repeats tasks.
And besides this one with wheels, they also talked about a bipedal model, perhaps for the consumer. They did mention it. Both are designed for tasks like reaching high shelves. The Alpha picks up things from the floor up to 2 meters high. Very useful for stock, right?
Absolutely. The Alpha has 29 degrees of freedom. These are the movable joints, interchangeable hands, one with 5 fingers, another like a gripper, depending on the task. 360-degree vision with RGB cameras and depth sensors. It's a very complete package indeed.
It looks like the UK wants to enter this race strongly, doesn't it? Without a doubt. It's a strategic move for them to establish a presence in this field that is currently very concentrated in the US and China. It's a bet on the combination of research, investment, and that startup agility.
They already have plans for the beta model in 2026 to incorporate feedback from the first industrial clients. It shows they are serious. Great. So, we have robots that are increasingly agile, more expressive, more focused on work, but for all this to run smoothly in the real world, it needs other technologies alongside it, right? Like energy.
Energy is fundamental, of course. And then we saw something very different from South Korea, from KIM, the Korea Institute of Machinery and Materials. That's KIM. Their idea is to use liquid air to essentially bottle electricity.
They built a pilot plant that makes 10 tons of liquid air per day. How does that work? It's an interesting concept called LAES, liquid air energy storage. The idea is to take surplus electrical energy from the grid, like from solar or wind sources that vary a lot, and use that energy to cool the normal air from the atmosphere until it turns into a liquid.
At what temperature? Quite low, about minus 196 degrees Celsius. Then this liquid air, which takes up much less space, is stored in superinsulated tanks. And to generate power back, when the grid needs it, they pump this liquid, heat it. It can be with ambient heat or waste heat from a nearby industry, and it expands greatly, like 700 times the original volume.
Wow, that violent expansion is what spins the turbines and generates electricity again. Amazing! Did Kim make any specific innovation there?
They highlight 2 things they developed themselves. It's a super efficient turbo expander that spins at over 100,000 RPM and a cold box with very advanced vacuum insulation to lose a minimum of energy in storage.
And for Korea, it's important to have this 100% national technology, to reduce dependence on foreign technology for strategic storage. And a clear advantage seems to be that it doesn't depend much on location, right? Unlike reversible hydroelectric power, which needs a mountain and a dam, or compressed air, which needs a cavern.
Exactly. You can theoretically build liquid air storage anywhere, near the city, near industry. It's much more flexible. And you can also use the leftover cold for refrigeration, maybe, or the heat from a factory to warm the air on the way back.
Yes, there is potential for these synergies to increase the overall efficiency of the system. It's an interesting piece for better integrating renewable energy into the grid, providing more stability. Of course, 10 tons a day is still a pilot, right?
Yes, it's demonstration scale, but it proves the technology works. Korea enters the race alongside the UK, China, and the United States, who are also exploring this liquid air idea. It's another step toward a future of cleaner and safer energy.
Changing gears again, moving away from energy and into interface. We saw something that looks like science fiction. The hololuminescent display is from Looking Glass Factory in New York.
I saw that. It's really cool. It's a thin screen, less than 2.5 centimeters, that shows 3D images that seem to float in front of it without needing glasses or anything.
Exactly. That's the magic. You can already imagine it in a museum, right? Showing an ancient artifact in 3D that you can view from various angles, or in an art gallery, I don't know.
Definitely. They have various sizes, from 16 inches up to giant ones at 86. Prices vary, of course, from about $6,000 to about $20,000. Still expensive.
Yes, but what's impressive is that feeling of presence of the 3D image, without glasses, without a headset, without anything. Connecting this with everything we're seeing in digital immersion. It makes sense. The line between digital and physical is getting blurrier.
Exactly. It's a strong trend to create more integrated, more magical experiences, as they call them. without the barrier of having to wear something. And to conclude this round of technologies, a very different approach to automation. A startup from San Francisco, Microfactory.
Ah, it's the factory in a box. This is a small desktop robotic system. The idea is to automate those manual, repetitive tasks that still exist a lot out there. Assembling circuit boards, soldering a little wire, organizing cables, tightening screws.
And the programming method is interesting. It's very direct. How does it work? A human operator just grabs the robot's arms and performs the movement it needs to learn, guides it physically. The system records the sequence called lead-through programming.
Ah, that sounds simple. It is relatively simple. Their CEO, Igor Kulakov, even mentioned they intentionally chose a non-humanoid robot to simplify the hardware, simplify the AI, and make the solution cheaper.
And accessible. And they built the prototype quickly too, right? 5 months. That's very fast. The objective is clear. Offer low-cost, easy-to-implement automation, perhaps an alternative for very specific tasks where an industrial humanoid would be an overly expensive and complex overkill. It makes sense for small businesses, perhaps.
Without a doubt, the potential is that bringing automation to a smaller scale, maybe even decentralizing production. That raises an idea. Which one?
Will we have microfactories and small companies in the future, or perhaps even at home to assemble personalized products on demand, like assembling the parts for my new cell phone at home? Who knows? It's a vision that challenges that model of mass production, all centralized. It's something to think about.
So, we've covered super resilient robots, robots with nearly human faces, robots that run and dance. We saw energy stored in liquid air, floating screens, microfactories. Phew, that was a lot. Taking a general overview of all this, what do we take away from this avalanche of novelties?
I think the main lesson is that none of this is happening in isolation, you know? They are interconnected trends that are mutually accelerating. The physical and interaction capabilities of robots are growing at an exponential rate.
At the same time, the support technologies, energy, interface, automation itself are creating the foundation for these robots to be not just cool prototypes, but practical tools integrated into our daily lives. It's convergence, right?
Exactly. And the speed at which this is converging is perhaps the most impressive. It's very quickly reshaping the landscape of automation and even the way we'll interact with machines.
And all this convergence leaves us with one final thought for everyone listening. Hit me with it. Considering the speed at which robots are learning, they show complex human movements, dancing, martial arts, as we saw, and this growing capacity to show expressions that seem real, what new forms of art or entertainment or
even companionship could emerge when all this finally comes together. Are we heading towards having, say, robotic artists capable of genuinely awakening emotion in us, further blurring the line between what we think is just programming and what we feel is authentic?
Wow, that's quite a question. Blurring that line between simulation and feeling. That's food for thought. This video doesn't end now. It continues with us talking in the comments. If you found this video interesting, I invite you to become a channel member and like this video. Up here on the top right, I'll leave a video suggestion so you can stay with me. I'll see you in the comments and in the next video. See you soon.